Welcome back to AI Verdict, where we separate the hype from the hardware. If you've been hearing all the buzz about some mysterious chip X from China that's supposedly 1,000 times faster than Nvidia, well, the details are finally out. So, what's the real story? Let's get into it.
So, a team of scientists from Shanghai Jiao Tong and Tsinghua University just dropped a bombshell. They've created a new kind of light-based AI chip called LightGen. And the claims are, frankly, staggering. They're saying you could outperform Nvidia's legendary A100 GPU by over 100 times in both speed and efficiency for certain tasks. Things like generating images and video.
But this story is about so much more than just a new speed record. The researchers themselves are calling it an architectural exit. That's a fancy way of saying they're not just improving on the old way of doing things, they're taking a completely different path to get around one of the biggest problems in computing today, heat. To really get why that's such a game changer, we have to understand why that exit is so desperately needed in the first place.
To understand why this announcement is making such huge waves, we've got to look at the current backbone of the entire AI boom, and that's the digital GPU.
Everyone knows Nvidia's A100. It is the undisputed workhorse of the AI world. It's flexible, you can program it to do almost anything, and it's got the power for today's giant neural networks. But as these AI models just keep getting bigger and bigger, scaling up comes with this massive, hidden cost.
So, a single Nvidia A100 board, just one, can pull up to 400 watts of power when it's really under stress. That's a lot for one component. But of course, no one is running just one of these things. Now, let's scale that up. Imagine a data center with, say, 10,000 of these boards. You're now pulling a staggering 3.5 megawatts of power continuously. That's basically the same electrical footprint as a small city. And that's not even counting the ridiculous amount of extra energy you need just to keep the whole building from melting.
So where does all this heat come from? Well, it all boils down to some pretty basic physics. Inside every one of these chips, you have billions of microscopic transistors that are constantly flipping on and off. Every time they flip, they leak just a tiny bit of electricity. Multiply that by billions of transistors flipping billions of times a second, and all that wasted energy turns into heat. Engineers call it resistive heat, and it's the fundamental reason why AI is so power-hungry and expensive.
And this is where photonics just changes the entire game. This isn't just a slightly better silicon chip. It's a completely different way of thinking about how to compute in the first place.
Okay, so instead of pushing electrons through tiny copper wires, which creates friction and heat, these photonic chips send photons, actual particles of light, through tiny little channels. And since photons don't have an electrical charge, they don't leak energy and they don't create that resistive heat. The really wild part is that the chip is doing math using the natural physics of light itself, like how light waves interfere with one another. It's pretty mind-bending.
Now, you might be wondering, if this is so great, why aren't we using it for everything already? Well, there's always been a catch. Historically, photonic chips were only really good for simple things because they could only process an image in these tiny separate little patches. When you tried to generate a full image, you'd have to stitch those patches together, and the result was always this disjointed, low-quality mess.
And this is LightGen's big aha moment. It gets around that whole fragmentation problem with this really clever 3D stack design. By stacking over 2 million of these photonic neurons vertically, one on top of the other, the chip can process an entire image all at once in a single go. The analogy here really says it all. The old way was like trying to paint a giant mural, one little tile at a time. LightGen is like a projector that displays the entire perfect mural instantly. All right, let's talk numbers, because this is where it gets really crazy. The LightGen prototype hit a throughput of almost 36,000 TOPS. That's trillion operations per second. Compare that to the A100's 300 or so. But the number that really makes you fall out of your chair is the efficiency. LightGen delivers 664 TOPS for every single watt of power it uses. That's a massive leap forward, and it's all because doing math with light just wastes way less energy than flipping billions of tiny digital switches.
And LightGen isn't totally alone in exploring this path. Another recent project, called Excel, took a slightly different hybrid approach. It combines photonic parts for the heavy math with some electronic parts for control. Now, it's built for a different job, simpler recognition tasks, not the complex image generation LightGen is designed for. But both of these chips are pointing in the exact same direction. Let light do the heavy lift.
But this whole story isn't just about physics and clever engineering. There's a huge real-world twist involving manufacturing and geopolitics.
And here is where the story takes a fascinating turn. Both of these new chips, LightGen and Excel, were made using older DUV, or deep ultraviolet lithography. This is a huge deal. Why? Because it means they don't need the absolute latest, most advanced EUV or extreme ultraviolet machines, the very same machines that are under tight export controls and sanctions.
So how is that even possible? How do you build a cutting-edge chip with older technology? Well, it's because this new architecture kind of sidesteps the whole problem. Instead of winning by cramming in the tiniest, most advanced transistors possible, it gets its performance from the clever design of its light-based circuits. It changes the rules of the game.
But, and this is a really big but, we need a reality check. A promising lab prototype is one thing. A mass-produced chip that's ready to be installed in millions of data centers is a completely different beast. Before we start writing obituaries for silicon, we have to talk about the massive engineering hurdles that are still in the way.
There are 3 huge make-or-break challenges here. First up, manufacturing precision. We are talking about aligning these components with nanometer-perfect accuracy. A tiny mistake, and the whole computation just collapses. Second is integration. All of our AI data is digital, so you have to constantly convert it to light, do the math, and then convert it back. And you can lose a lot of those efficiency gains in that conversion process. And finally, the big one. This chip is a specialist. It's a one-trick pony. It's amazing for visual tasks, but it can't train a large language model or run the kind of flexible code that makes Nvidia's GPUs so versatile.
Okay, so let's bring it all home. We've seen the hype, we've seen the hardware, and we've seen the hurdles. What does this all really mean for the future of AI?
Let's just ask the big question right out loud. Is the Nvidia A100 obsolete because of this?
The short answer is no, not even close. Nvidia still absolutely dominates the world of general-purpose AI. And maybe more importantly, they own the entire software ecosystem, CUDA, that millions of developers rely on. LightGen isn't coming for that throne. Think of it as a new, highly specialized tool, an accelerator built to do one specific thing, visual AI, with incredible power efficiency.
So if it's not an Nvidia killer, what is it? Well, its true potential is all about economics. If, and it's still an if, chips like LightGen can make it out of the lab and into mass production, they could completely redefine the cost of doing certain kinds of AI by tackling one of the biggest line items on the bill, electricity.
So what's the final verdict? The future of AI hardware didn't just get faster, it refracted. It bent in a totally new and fascinating direction. This isn't just about one new chip, it's about a whole new way of thinking about computation itself. For more deep dives into the hardware shaping our future, make sure you subscribe to AI Verdict.